Hello, dear students. Today we have Proposition 43, Book 1, Proposition 43, which states the complements about the diameter of any parallelogram are equal to each other. A new word, complements. Here's a parallelogram. Here's a diameter, okay? And then if these things would be called the complements. They're parallels, and these are parallels. But these are the complements. The complements just touch the diameter. Remember the diameter. Whereas the other parallelograms are about, they surround the diameter, okay? And one thing to notice is that the parallelograms that are not the complements, they're always mimicking the shape, and we'll talk more about that later, proportion. They're always mimicking the shape of the whole parallelogram. So here you have a whole parallelogram. Here you have a little parallelogram, another little parallelogram, okay? Once you get those two, you end up having complements. And even though the imagination doesn't immediately say that those two complements are equal, they are indeed equal. And that's what we're going to prove today. Okay, I tried to color code this for you, and it's a little bit complicated. It's the same drawing over here, large, and I color coded it for a reason, and you'll see. But you see these complements? Okay, so here we have a parallelogram. We've drawn the diameter, and we've made our little parallelograms by drawing lines parallel, right? This is parallel to this, and this is parallel to this. Once you do all that, then you get your non-complement parallelograms. And you say, then you have your complements, and your other parallelograms that are about the triangle itself. And what you want to prove then, what we're going to prove is that this is equal to this. Here's a parallelogram, here's a diameter. We've drawn the other little parallelograms by drawing lines parallel to the original parallelogram. And then we end up having extras, the extras that just touch the diameter. And those extras are equal to each other. Let's prove that. To do that, we just need one. We're going to rely on equals added to equals or equals, and equals subtracted from equals or equals. I didn't put that here. And then we're going to use the proposition that we've used in the past, that in any parallelogram, the diameter bisects the parallelogram, okay? Great. So, let's look at this big parallelogram, okay? Here's the diameter, so this triangle is necessarily equal to this triangle because the diameter bisects the parallelogram. So here you have one half and the other half equal to each other, okay? This triangle, big triangle, is equal to this big triangle, okay? Now, let's abstract. The trick to this prop is to be able to, with your intellect, say, imagination, just look at this right now. So imagination, just look at this little parallelogram, okay? And this diameter. We know that this is equal to this because the diameter bisects the parallelogram. Great. Now let's look at this little parallelogram, okay? And this bisects it. This is the diameter. So this is equal to this. Great. So we got a bunch of stuff equal to a bunch of stuff. Let's start adding equals to equals. So if this equals this, and this equals this, then this plus this equal this plus this, okay? So if this triangle equals this triangle, and this triangle equals this triangle plus this triangle are equal to this triangle plus this triangle. So this shape right here is equal to this figure right here. The figure is equal to the figure. Great. But the whole of these two little things, is equal to the whole of these two little things. Okay? So we've got this big triangle equal to this big triangle, and these two parts of it are equal to these two parts of the other one. Okay? Big triangle equal to big triangle. This equal to this. Let's subtract the parts that are equal. Let's subtract these out. And all that you have left are these, which are the complements, which are necessarily equal because equals subtracted from equals, the remainders are equal. Complements are equal. We can do that one more time over here if you want, if the colors don't help you. So here you have this being equal to this, and this being equal to this. Let's subtract the equals out of the wholes. Then the remainders are necessarily equal, which are the complements. Thus we have shown that in any parallelogram figure, let me look at the camera because we're talking about the universal. Notice how we go from the particular to the universal. The intellect sees, that's true in any case. No matter when you have it, that's when you grab the universal, okay? So, in any parallelogram, the diameter, the complements about the diameter are equal to each other. Repeat, in any parallelogram, the complements about the diameter are equal to each other. These little guys are the complements, okay? Thank you so much. Bye-bye.